Hi, and welcome back. One of the things that we're going to talk about today is about the concept of time. Most Java books actually even skip this part. I don't know why they do that. To me, if you're really learning how to program, you have to learn one of the most human data types that there is, and it is basically the introduction of time. Time is one of those things that doesn't only represent time the way that it passes by, but also we use it for many different things, and it's also very relative. An example of things that we use that are not accurate in the way that time represents something is, for example, distance. How far away is downtown Los Angeles? You might say, oh, about 20 minutes without traffic. So it's not really that we are looking for a way to utilize time for just more than how old are you or what time of the day it is. Time is also one of those things that written very differently regarding time, but mean exactly the same thing. So for example, in the United States, the date format is month, date, year, whereas in Europe is day, month, year. But they mean the exact same thing. Or sometimes we use slashes to divide certain things, or sometimes we use dashes. So to me, the concept of time, it is very important because in a global world, time is money. So let's get started. How do we represent time internally? Because as we have known, we have zeros and ones in a computer. And the biggest challenge with those zeros and ones is that we can use them to represent strings or represent, we already know that the primitives are int, boolean, double, long, float, etc. But then how do we use that to represent time so that we can put any time from January 1st, 1900 all the way to 2020? The easiest way that computer scientists came about representing time is by having a counter. This goes back to when Unix was invented. There was this concept that is known as a Unix epoch time. And what that represents is the time zero means January 1st, 1970 at midnight on GMT, or Greenwich Meridian time. And then after all that, we are elapsing seconds since that have passed since. So for example, in here we can see that there are seconds since January 1st, 1970. When I wrote this slide, which was November 22nd, 2017, a few years ago, this was a representation of that time. And this is in seconds, but reality is that in a second, a computer can do a lot. And as a perfect example, let's just launch Chrome, and then we can say, Java epoch time. In a second, computers can do a lot in 1 second. So Java decided that because computers are fast, that we needed to use milliseconds as the base unit. So basically you grab the previous number, this one that ends in 200, and multiply it by 1,000, and all of a sudden you have the same date, but now it's represented in milliseconds. 1,000 milliseconds is 1 second. Then how do we represent that in Java? Well, the writers of Java initially, and if we go to our project and we start anew, and we are gonna say date sample, and we go and put main. If we write in Java a new date, or the writers of Java created the object date, and there are a couple of different projects, one for SQL and one for Java util. We choose the one from Java util. That's the one that represents a date, and we can say date now equals new date. And if we leave it without the parentheses and we print that list, we can see that right now, the moment that this object was generated was Saturday, April 18, 2020 at 9:52 p.m. So that's just a basic way of generating a date. Now, if I want to go under to the amount of milliseconds that it was, I can just use get time, and that's going to print a long number that has that value, and it is this one. Why is it a long? Well, if you guys remember from our slides on the primitives, and let me just open it up. And this is from the first class. We can see that a long can go from -9 quintillion to 9 quintillion, meaning that because it has such a range that, if you have something like this where you have a number that it's 9 quintillion, and then from 9 quintillion to -9 quintillion, that is basically the range that is represented via 8 bytes. So 8 bytes are representing -9 quintillion to 9 quintillion. So basically, that gives us a very big range to represent any date that we want. So if we were to create a date that it's like really, really, really old, let's grab the same number and just put it with an L for long, and let's just see what date it gives us printed. $1919, and we can keep going, like doing that weird number, and it's taking us to 1666, and we can even add another number just because of the range of this. It keeps going back in time. Okay, so basically what we're seeing is that we can use time to go back or represent in the past and in the future. So basically that's what we are trying to represent when we have a date. This is, if you guys remember my conversation about low level versus high level, where we have things like new date 10,000, whatever number it is, right? This is very low level. We're actually speaking in the computer language. In reality, when we talk about dates, we have like date formats like 2020, 16, 10. If we want to format a date with year, day, month, which is not very orthodox, or we want to represent it as December 1st, 2020. Like if we were going to represent it in our terms, or even slashes, if we wanted to represent it in our terms, we would go into more of a higher level. Because of that, there is this class called the date formatter, and the date formatter allows us just to define a little language, allows us then to pass any strings that will be interpreted as that language. So for example, we see here in this simple date format that we are going to be using, because of this right here, and then this DD and YYYY, that it represents with this means 2 digits of month. So if I use month that means that 2 characters are going to represent that. If I use DD, is 2 day in months, like this 1105, and then when I use YYY, 4 characters, it is a year. So the time machine invention, according to Back to the Future, I can now pass a date in that format. And if I know that if I'm scanning a log or something like that, I can very well use that formatter for that purpose. So why don't we give it a try in the code. So if we use, again, this part, let's try date formatter, df equals new simple date format. Why is the class here different? Because this is an abstract class. And then we say what format we're gonna do. We're gonna do mm dash. We're gonna use the dash just for a different thing, and then YYYY. And when we have that simple date formatter, okay, df.parse, we can say 0505 1979, just as a sample of a date. And we can say now that this date will be, because this function is going to return a date. I'm getting this by pressing command and highlighting, this little hand hyperlink thing pops up. When I stop pressing the command key, I am not getting that. When I press the command key and I move my mouse, I get that. So it's telling me that it's going to return a date, and it's going in here. So I'm going to return that, and now I'm going to give it a name variable. So it's date, and I can now do out sample. Okay, so a couple of notes. Why is this class different than this one? Well, if we go in this definition by putting the command key, we go in and click on it, we're gonna see that the class that we just are looking at extends date format. So basically this class is the same as this one. We're just putting a generic placeholder. It's essentially like saying, it's essentially the same as saying human JC equals new Juan Carlos. You know, that is the same, you know, because I'm a human, I'm still being held by such reference. So right now this reference is holding, even though that it looks like if it would be a different class, it's the same, it's just a different name. Second thing is that we're getting this red line. What this is telling us is that there's an unhandled exception called parse exception. So if we alt enter, we're gonna get some options. So I'm gonna say that add exception to the method signature for now, just for now. That's gonna be the solution whenever we get that exception thing. The reason being is that we want to learn exceptions in a little bit further out in the classes. So by adding that, it adds this line that essentially removes the exception handling issue. Right now, it's a chicken and an egg situation. You should learn just that right now we go around it by doing this, and now we go right click and run it. And we get May 5, 1979, which is the date that we were passing. Okay, so another thing that happens with date and time is that we use time in a very relative way. Like I said, we say even for distances or things like that, but time is also very relative in terms of like how long until New Year's, or how long until, I don't know, in a week from now, or next month, or last year. You know, things are relative as far as time goes, which is also what makes it really interesting to make sure that we study it. So the thing that I wanna talk about is that the designers of Java very quickly realized how outdated the date class was. So if we go into Google and look for Java Date API, we'll see that basically everything in the class is deprecated. The class is still useful, but it's just a general placeholder for a date object, but not, you cannot really rely on minutes, month, seconds, time, etc. because as of Java version 1.1, right now we're in Java 11, it's deprecated, it's removed. Technically, you should not be using it. It's not going to be maintained. Why is that? Why did they write all this code and immediately deprecate it? Well, they realized one thing, that the world does not revolve around one country. There's time zones. The date and time is quite complex, so you need a bunch of different objects to like really take control of it. Okay, so basically what they came up with is this idea that you have a calendar, just like any app, and in that calendar you have a date and time that it's selected, and it can help you to move relative to that point in time. So the class calendar is basically the same as this, where you have, you know, a date and you can move around. If we want to really visualize how the calendar object works and why is it different than the date object, the calendar object basically has a date, it's a wrapper around a date object, and this is the calendar object. So there's a date that it's the current time, and it has a bunch of convenience functions to represent or to help manipulate that current time. And the date object has essentially a long inside of it, which is the current time represented as a long. So basically what we're seeing is that the calendar object, because of this consideration here, has a date object, and that date object has a long. And this is where it gets a little bit confusing, because they decided to use the getTime function to access this object, and from the date object we use the getTime to access the long object. So basically we're using the same function twice to get to the same thing. But when we're dealing with dates, it's important that if we're doing a date difference between a calendar and a date, that we always compare apples to apples. In other words, let's look at it in the IDE. So we have a calendar and we're saying C equals calendar.getInstance, and that's the object that we're going to be using. If we were to print this and we did C.getTime, we're going to realize that it's essentially the same as the new date object. It just selects the time that you are creating it. By using the get time here, I just get the current representation. But if I want to then dive in again into this level here, then into the long, I can then do .get time. So that double get time is now gonna give me that long number, which basically it is from when I do get time, it gives me the date object, and then I do get time and it gets me the long. So now given that, I can start manipulating it to be relative. So I can say C dot, we can add, say, 1 week amount. So you can see actually C dot add, you can see that the type of field and the amount. So the type of field, we're gonna go for a static member that it's calendar.week, week of year, and then we're gonna do 1. And by doing that, we're adding 1 week to the date. So if we do south C.getTime, time, now we're gonna see that it's gonna put the cursor of the calendar 1 week later. So you can see by doing this calendar dot whatever, you can manipulate basically any value. So for example, year, we're gonna go 10 years ago, 100 years ago, to make it like really evident. And now we can see that we're adding 100 years by making it to the year 2120. If I go minus 100, then it's gonna go to 1920, and so on. So this is a way that we can manipulate by just using that. Now, if we wanted to just completely reset the time, and if we went to our sample where we're doing date format, df, new simple date format, and we do 11 month, day, year, and then we did like that df.parse, and then we did 11/11/2019, and we did, and I'm just choosing a random date, it has no meaning or anything, and we did date, new date, and then we can then say calendar.set time, and we can say new date. So now we're gonna see that we are going to November 11 of 2019. Now, if we want to know what was the day of the year in 2018, just we can, or let's say 1,000 years before. Let's go a little bit more extreme. So if we go c.add calendar.year, and then we do minus 1,000. We're gonna see that 1,000 years in November 11, 1019, it was a Wednesday. So you can see how using the calendar object allows you to be flexible and to manipulate date and time with ease. One thing that it's really important while troubleshooting code and really measuring how long something took to run in a computer, we can convert it all into milliseconds and then figure out what was the actual runtime. Let's assume that we are going to have this code. So we're going to be printing this X thing, and it's going to be very fast. So maybe let's just add a couple more zeros so that way we can simulate that it's something that was running a little longer. So we want to measure how long that function took to run because it was processing 1 million numbers. So what I'm going to do is that I'm going to create a date. I'm going to call it pre, and I'm going to do new date just to generate the timestamp before we run that, and then the timestamp that we go after that post time. So if we want to do the difference between both, we can do a long, because we're going to get difference, and we're going to do post.getTime minus pre.getTime. So now we're getting the difference in milliseconds of both. And if we want to translate it back into seconds, we can do diff or long diff in seconds equals, and actually let's do double, because we want to do diff divided by 1,000, and we're .0, so that way it's a float. And then let's print how long our difference in seconds was. Remember, these guys are milliseconds, so by doing that division, we are turning it into seconds. If we wanted to go into hours, we would divide by 60, and then by 60, by minutes, this is minutes, this is hours, and this is 24 seconds. So we can always keep going, 24 hours. So we can keep going and changing the time into whatever we want, but in this case, we just want to look at how long did this process run at the end of it, and it took 3.34 seconds. So that's useful to see, okay, well, if we're trying to troubleshoot performance, let's just remove this guy, and you're gonna see how dramatically faster it becomes. If we're trying to troubleshoot performance, you see just printing to the command line made it as slow as it was, but otherwise it would just compute things so fast. But the idea here is that it allows you to quantify how efficient your code is. And that's also one big reason why I wanted to do this topic. Because in this topic, it is really important for measuring how we're dealing with the speed of time or the speed of execution with our code. And earlier I was talking about how the writers of Java didn't consider anything beyond just one time zone. So they realized that the world was much more connected, and given the internet, like, it was much more important to really go into global time zones and be able to change things. So Java introduced also the concept of a new time zone, of time zones, and they introduced the idea of an instant, where an instant is basically a non-time positioned datetime, and then it allows you to convert it easier to a time zone. So this is where I think that Java, for example, is more verbose than others. But for example, let's try to find out currently what is the current time in, say, Paris, France. So if we create an instant like this guy, by pressing Alt Enter, I can import it, and now it's imported up here, so now it's not red anymore. And then I can use TimeZone TZ just to get all the time zones. We're going to import the class using Alt Enter the same way, and then TimeZone get time zone, and let's do let's actually list all the time zones. So let's do time zone get available IDs, and this is going to return a string array. So now we're gonna just essentially put it on this thing. So we're gonna print all the available time IDs. Arrays to string, and we're gonna put this guy here, and we're going to run the thing. What this thing is doing is that it's formatting the data, the arrays, into something readable. So we're gonna put like Paris. It's Europe/Paris. That's the one that we're gonna use. So if we do TimeZone dot get time zone, and we put this ID, and then we put like TimeZone TZ. We're referencing that time zone that we want to do, and we can create a local datetime object, which is one of the newer versions of the datetime objects, specifically made for dealing with different time zones. Let's go LDT, I'm going to call it, for localized datetime. And then I'm going to do local datetime dot of instant. And I can pass an instant and a zone ID, which is what I'm getting here as a time zone. So I'm going to put the instant and then TZ dot to zone ID. And now I can reliably tell you guys that right now in Paris it is 7:26 of April 19. So if we go into here and we do time in Paris, it's 7:27 a.m., which is basically the same thing of what we have here, just, you know, we took a minute to get it into that screen. So that's one way of getting the time zones and the dates converted to a local time zone. So for the next exercise, we're going to be doing something very simple. There's a couple of things that we're going to do. One, we're going to have the exercise where I want you to write a countdown towards New Year's. And in that countdown, we are going to print the date basically with what you've learned. And the important thing here is the exercises. So you already know, like if I ask you, okay, how far away are we from New Year's? And today, right now, for me, it is April 18. So it's basically April, May, June, July, August, September, October, November, and December. So we've got 8 months, 12 days, 1 hour and 32 minutes. That's basically how my countdown would actually do it. I know how to solve it by hand, and so do you. If I ask you how far away it is, your birthday, you probably would know. So the idea is to now, utilizing the tools that I just presented to you, to count this and create that exercise. And then the next thing is another exercise that you constantly do whenever you go to you are driving around. The idea is, these were the rates of 2017 in Santa Monica 3rd Street Promenade, and these were the actual rules. I copied them because that's how much it costs you to park there, and you wanted to more or less know, okay, well, how much am I going to pay? This is basically the rules in Santa Monica, so I would like you to write the rules that will tell you, given a specific time, this is just using a sample, but I would like you to just be flexible with the time. So where I am saying, okay, I parked for 3 hours and 10 minutes, how much am I gonna pay? Also, what happens if, I want you to consider all the cases where even if I leave my car overnight, how much am I going to be paying? And also, I've seen the examples of these cases that sometimes are handed to me where sometimes the parking garage would have to pay you, which is absolutely incorrect. So I want to make sure that you consider all the possible scenarios in order for you to become a solid programmer, and then write the code that I could basically change how many hours, minutes, and whatever I was parked, and it would give me the total amount that I need to pay. Okay? All right. Thank you for watching. See you next class.